Welcome. Today we're going to talk about lesson 2.4, where we are going to discuss the chain rule. So we're going to start first with theorem 2.10, which we're calling the chain rule. Now, the chain rule, it states that if y is equal to f of u, which is some function, and it is a differentiable function of u, and we have u is equal to g of x, which is a differentiable function of x, then y is equal to f of g of x is a differentiable function of x. And there's a couple ways we can write the notation for the derivative. But really what this is saying is if we have a function that is a composition, it's a composite function of two others, and both functions individually are differentiable, then the composition of the two functions is differentiable. So the different notations of writing the derivative using the chain rule, we can have dy dx is equal to dy du times du dx. And all that says is if we're finding the derivative of y, that's the dy, with respect to x, it's equal to the derivative of y with respect to u times the derivative of u with respect to x. We can also write it as the derivative with respect to x of f of g of x is equal to the derivative of f of g of x times the derivative of g of x. So we would find the derivative of f and the derivative of g, but when we find the derivative of f, we put g of x in for any variables. Let's look at an example. So this is example 1. We're going to look at a few different functions here. Our first function, example 1a, we're going to have y equals 1 over x plus 1. So we're going to find dy dx, or y prime. And to do that, what I'm going to do is I'm going to let u equal what I have in the denominator, x plus 1. And I'm going to let y equal 1 over u. So I'm just replacing whatever I'm letting u be in my function with u. I'm decomposing my function. So if I want to find y prime, what I need to do first, I know y, if it's 1 over u, that's the same as u to the negative first power. Y prime is going to be, well, let's just think of the chain rule. We've got f prime of g of x times g prime of x. Now, we can think of u in a way as g and y as f. So if we're trying to find the derivative of this function, let's find the derivative of both our u and our y. Well, f prime, if y is the same thing as f, is going to be negative u to the negative second, and then g prime is going to be 1. So let's take everything we know. We have y prime is equal to f prime, which is negative u to the negative 2, times g prime, which is 1. Now I'm going to replace my u in my derivative with what we said u is equal to. So we're going to have negative x plus 1 to the negative 2 times 1 is just going to be itself. Now let's take care of that negative exponent. So we can rewrite this as negative 1 over the quantity x plus 1 squared. So we've used the chain rule and we've found our derivative. Let's look at another function so we can see how this chain rule does work. So we'll call this example 1b, where our function is going to be y equals sine of 2x. Now, what I'm going to do is I'm going to let my u this time equal 2x, and I'm going to let y equal sine of u. So remember, u is like our g, y is like our f. So if we're looking for f prime, well, the derivative of sine is just cosine. So cosine u, and g prime is going to be 2. So when we're looking for y prime, we're going to have f prime of g of x times g prime. So let's take what we know. We know f prime is cosine u, and we know g prime is 2. So this is the same as 2 cosine u, and then I'm going to just replace u with what we said u is equal to. So we're going to have 2 cosine of 2x, which we have found our derivative. Let's again look at another function. So this will be example 1c. Our function will be y equals the square root of 3x squared minus x plus 1. I'm going to let u equal our 3x squared minus x plus 1. I'm then going to let y equal the square root of u. Now y, if it's the square root of u, that means it's also u to the 1/2. Now keep in mind, g is like our u, f is like our y. So if we want to find f prime, we're going to have 1/2 u to the negative 1/2. If we want g prime, we're going to have 6x minus 1. Now we're going to use these to find y prime. Remember, y prime is f prime of g of x times g prime. So f prime, we've got 1/2 u to the negative 1/2. And we're going to multiply that by 6x minus 1. Now, that first part in the parentheses, let's clean that up a little bit. We can rewrite this as 1 over 2 square roots of u times 6x minus 1. Through multiplication, we can write this as 6x minus 1 over 2 square roots of u, and then we can replace u with our 3x squared minus x plus 1. So our full derivative is going to be 6x minus 1 over 2 square roots of 3x squared minus x plus 1. And we're done with that one. Or I'm going to say we're done. Let's look at another example. We'll call this example 1d. Our function is going to be y equals tangent squared x. Now, if I'm going to have a trig function involved, and that trig function to a power, I'm going to actually let u equal my trig function. And then I'm going to let y equal u to whatever power the trig function is raised to. So that way when I'm finding my g prime, if we're letting u be the same thing as g, that derivative is going to be secant squared x, which we learned in our last lesson that the derivative of tangent is secant squared. And then if I'm letting f be the same as y, then f prime is going to be 2u. So when we're looking for y prime, we're going to have 2u times secant squared x, and then we can replace u with tangent. So our derivative is going to be 2 tangent x secant squared x. And then we're all done. I've got one more in here we can look at. Let's look at example 1e. We'll have y equals the quantity x squared plus 1 cubed. If I do have parentheses involved, what I'm going to do is take whatever's in parentheses and I'm going to say that is equal to u. So here I'm going to have x squared plus 1 equals to u, and then y is going to equal u cubed. Again, we'll let f represent our y and g represent u. So if we're looking for f prime, that's going to be 3u squared, and g prime is going to be 2x. So when we're looking for y prime, we're going to have 3u squared times 2x, and then we'll replace u with our x squared plus 1. But first, I am going to clean this up a little bit because I can multiply the 3 and the 2. So we're going to have 3 times 2x u squared, which is just the same as 6x u squared. Now let's replace our u with what we have above. So we're going to have 6x times x squared plus 1 squared. And then we are done with that one. Pretty awesome. So this chain rule is nice when we have something that's a little bit more difficult. Let's look now at our second theorem, which is our only other theorem in this lesson. So this is theorem 2.11, which we're calling the general power rule. So what we say is if y is equal to u of x, and that's raised to some power, n, where u is a differentiable function of x and n is a rational number, then we can write the derivative as follows. We can write it as the derivative of y with respect to x is equal to n times u to the x to the n minus 1 times the derivative of u with respect to x. Or we can write it as the derivative with respect to x of u to the power of n is equal to n u to the n minus 1 times u prime. Let's check out an example of this. So we'll call this example 2. We're going to have the function f of x is equal to the quantity 3x minus 2x squared cubed. So in here what we're going to do is we're going to let u equal the stuff in parentheses, 3x minus 2x squared, meaning then that u prime is going to be 3 minus 4x, and then we're going to let f of x equal u cubed, so f prime is going to be 3u squared. Now when we're finding the derivative of this, f prime of x, we're going to take our f prime we had over on the right, 3u squared, and we're going to multiply that by our u prime, 3 minus 4x. Now we're going to replace u with what we know u is equal to. So we're going to have 3 times the quantity 3x minus 2x squared times 3 minus 4x. And that is our derivative using that general power rule. I think we have enough time to look at one more example. So example 3, we're going to have the function f of x is equal to the square root, no, not square root this time, cube root of the quantity x squared minus 1 squared. Now we can rewrite this as the quantity x squared minus 1 to the power of 2 thirds. Think back to Algebra 2. Now from this, I'm going to let u equal the stuff I have in parentheses, x squared minus 1. So u prime is going to be 2x. And then f of x is going to be u to the 2 thirds, which means f prime is going to be 2 thirds u to the negative 1 third. So when I'm looking for my final derivative, f prime of x, we're going to take our 2 thirds u to the negative 1 third, and we're going to multiply it by 2x. Now I'm going to clean this up a little bit. I'm going to rewrite this as 2 over 3 cube roots of u squared times 2x, which I can also just write as 4x over 3 cube roots of u squared. And then I'm going to replace my u with what we said u is equal to. So we're going to have 4x over 3 cube roots of the quantity x squared minus 1 squared. And that's our final derivative. And we're going to finish this video on this example. We'll pick up with example 4. We're going to keep looking at more examples of the chain rule, utilizing this general power rule in our next video.